Hey there, my wonderful students. Welcome to topic 5.4, Cladistics. I mentioned these briefly in the last notes when we were looking at how we classify organisms and that sideways branching tree. So we're going to look at that today. I want to give you a little bit of a warning. So I'm using Mrs. Paulson's, Mrs. Durkee, Mrs. Paulson, and Mrs. Gullick all have taught IB Bio, and so we use common lectures and PowerPoints. And this one is fancy and it's a little bit longer. So I'll warn you in class, I probably want to break this up into two, but I do want you to, as you are, here, let me open this up here. As you are taking notes, to pay attention to like some superfluous words, right? So things that you might not need to write down, and then some things that seem important, some things that can be grouped together, all right? So as always, I would encourage you to kind of pause it when it gets to a new slide, like kind of scan through the content, write down what you think is important, and then listen and add that over it. Okay, so cladistics, more ways to classify and group the organisms. Okay, here, let me go like this, and here we go. Okay, so here's kind of what we're going to go over. So you don't need to write this down, but before you're done with this lecture, you should have a good understanding of what is a clad, what is a cladogram, how do we use structural evidence, and meaning like we've already talked about homologous and analogous structures, convergent and divergent evolution, and then how we use molecular, right, like DNA, and then because of all those things, how we reclassify them. So that's what we'll be going over in this lecture. Okay, this is funny. I'm sorry. Okay, all right, ready? Okay, all right. So let's start with cladistics. So a file. Kind of going back to, I know I mentioned this in class, but on Quizlet, let me go like this, hide this. I posted the Unit 5 vocab. And so if you've been confused on like, what is a vocab word? What's important? So when we highlight those things, that actually lists out kind of like the main topic, the most important things you need to know. So if you don't want to highlight now, that's fine. You can go back and like cross-reference it with Quizlet. That might be a good idea. All right. So a phylogeny describes how a species had changed over time, right? It's like evolutionary path, right? And there's a couple different ways to do that. One of them is a cladogram, and that's what we're gonna learn how to make them. Right in the last one, we looked at those the dichotomous keys. Now we're gonna learn how do we put together a cladogram. We'll look at a lot of examples in class. Again, this is something that you just need to be able to read, right, to be able to tell common ancestors, right? So the cladograms are also called phylogeny trees. So you might see those two terms kind of used interchangeably, and they can either be based off of structure or molecules, right? So looking at the structure of an organism versus like the DNA and the changes over that. But we are just looking at relationships of how the organisms have changed over time, how organisms are related to each other, and the order in which they have evolved and then became different species, right? So there's a lot of different possibilities in these cladograms, and the study of that thing is called cladistics, right? So we're going to look at that throughout this lecture, all right? These are examples of clads. A clad is kind of, you can think of like it's a group, right, that have evolved from a common ancestor. And how you can tell that a group has evolved from a common ancestor, right, is that they are grouped together and they have this convergent, like, what I'm going to say, like junction right here, right? They're called nodes here. But so basically I can go like this, and these two came from here, right? And then I can go even bigger and say, well, these two and these two came from this common ancestor, right? These are not clads, right? Because this one came from this common ancestor. These guys came from this common ancestor. So anytime like it comes together, a line comes together, you can think of that as like an organism, and everything that goes back to it is the common ancestor, right? So the ultimate common ancestor would be at the bottom of the cladogram, but they're called clads when it's just like a little node here of when they intersect. Okay. How we know common ancestors, like every time it branches off, they possess common traits, right? And because of like how they have evolved over time. We're going to look at some more examples, but again, if you can trace it back to coming together to an intersection, right? Those two are common ancestors here. These are all common ancestors of this one, but these two are not, right? These do not go under clads. They're not called, with the come to interjecting node. I just realized my face is over that one. Let's see if I can move those around throughout the lecture too. Okay. All right. I don't know if I can. I just tried to move it. All right. So in cladograms, each branch point represents an event that created divergence to create a new species, right? So speciation is the creation of a new species when they no longer can breed together, right? So that's how we defined it, I think in 5.2, maybe 5.1, right? And so these branches here, right? So at this point, so we have common answer, let's start here. We have the fish, it moves along, and at this point, right, it becomes a new species, right? Again, we talked about how it kind of goes as like, you're reading it as like a book, right? It goes this way. And the evolutionary event, right? You can actually look at the key here. So we have the evolution of limbs, right? So that's when the amphibians, not just frogs, sorry, amphibians branched off from the common ancestor of the fish, right? And then we keep going down here. We see reptiles and birds. And in that one right here, we're seeing because they have eggshells. So we look at these very structural, this one is structural, right? And how they moved along. So that process is called divergence. The closer they are on the branch, the more closely they are related, right? So let's see, fish and amphibians would be more closely related than fish and birds, right? Reptiles and birds would be more closely related than reptiles and primates. So the thing that they're closest to, we say it has less divergent, and they are most similar. Okay. Now, how you actually construct a cladogram. So again, we're going back to structural or molecular. Like this slide is like very overwhelming, but I want you to again, like stop, look through it. Remember, we talked about anytime we see a graph or a graphic, like let's just pause and tell us, what is this trying to tell me? Right? And so here is how we could like go about creating a line, right? Like creating a cladogram to see which have. So we have these different characteristics: lungs, endotherm, and hair and fur. And then we check off, right? Does a fish have any of these? Nope. Does a lizard? Yep, but just this. What do birds have? What do rats have, right? So this is compared in a table. And then I can say like, well, this came first, then this event, then this event, and this event. And the event is lungs, endotherm, and hair and fur. So you can put that into a line and actually branch out the event. Remember that it's an event, and then it goes to that organism, right? Or that classification or broad category of organisms, okay? The other way is with molecular, so that's structural. The other way is molecular. This looks a lot more like, right? In this case, like, again, what are we looking at here? We are looking at mutations, right? So how many different mutations there are from the original, right? So here's, right, the rodent right here. And then we go to the bird. There's one different, like, so look at, oh gosh, I can't find the star. That's like this. See, these are the same here. These are the same. These are the same. We get to, which one's not? This one. So I have one, molecular difference there. It's not going to let me go back. Previous. There we go. Okay. So I have one molecular difference there, right? And in this one, you find 3 differences. And in this one, I have 4. So again, the more different they are, the further they are apart from each other in the evolutionary line. Okay, hold on just a second. My phone is reading. Okay, Miss Myers has to go sub-second period. So let's see if I can get through this. All right, so when we look at those cladograms, we can actually look at evolutionary relationships based on their differences. All right, so these are just 2 examples, but things that you will have to be able to read, be able to analyze and say, what is the common ancestor, which ones are most alike, which ones are different, right? Okay, so structural characteristics. We'll go. So this is an example of the slide, like for the love of writing. Do not write all this down, right? Pause. Right? Pause, and then look through and say, okay, what do I not know? What do I not have in my notes, right? We have already looked at structural differences called the homologous and the analogous, right? So historically, classification was based on their structural differences, right? We talked about how technology has changed, and therefore now we can look at molecular, but because we are looking at structures, we can get some type of error, right, in that. So the closely related species were expected to have similar features. However, we talked about things like that are analogous to structures like like fins, right? So the fin of a whale is very different because it has the structure within it, right? You guys, you drew that one out, right? Versus the fin of a fish, right? So they look the same, they do the same thing, but they are not structurally the same, right? So closely two related organisms may have distinct features, right? So the homologous structures, and this is called adaptive radiation. That is a vocab word. So make sure you have this written down. And this is rapid divergence, due to like an ecological niche, right? So ecological niches are places that are secluded. They're very different ecologically speaking than those around them, right? Ecology, right? Thinking about like the plants, the weather, like all the things that make up an ecology. And it happens very quickly because it's secluded. So we talked about in areas of like islands, right? Where all of a sudden there's a rapid divergence because there's a change in niches. Now, distantly related organisms may have similar features, the analogous structures, right? And that's because of convergent evolution, which is common selective pressures, meaning like you are going to the common selective pressures, like there's water. So they're going to need the fin, right? But it doesn't always correspond with evolutionary origins. Okay, so those are part of the structural characteristics. There's no way I'm going to get through this before I have to go sub. Okay, we'll do one more and then I'll go. Okay, so just to review, we already talked about analogous versus homologous. So maybe you scan through here and see if there's anything that you're missing from your notes, right? So homologous, same anatomy, different function. Analogous, different anatomy, same function, right? These are the two things I just talked about. Share a common ancestor, do not share a common ancestor. Arise divergent, arise via convergent. So maybe make a quick chart that you have kind of like hit on those highlights, and then you can go back to your old notes and make sure you have those things there too. Okay, all right, so we'll look at this last thing and then I'm going to pause it. So convergent evolution is where I have an independent, okay, never mind. I'm going to pause it, I'll come back. I'm back. And I have no idea where I stopped talking because I had to go sub. So Mrs. Myers is going to stop this lecture and make it a two-parter and go back and listen and see where I left off. Oh, this is fun, flexible and fun. I'll see you guys soon.